This is part 5 of the series Permutation and Combinations. Today I am going to discuss a few questions from the 2017 statistics paper, which is paper 6. Okay, the first question says 8 children of different ages stand in a random order in a line. Find the number of different ways this can be done if none of the 3 youngest children stand next to each other. Okay, you want the 3 youngest children to be separated. So apart from these children, there are 5 other children. Okay, so I'm going to first make them stand in a line. So 5 factorial for this. Now if I just see where can the rest of the 3 children, which are the youngest children, they can stand so that they are not next to each other. So one possible place is this, the second is this, third, fourth, fifth and sixth. Now if you look at the first youngest child, he's got 6 different options. He's got 6 different places where he can stand. The next one has 5 different options and the last one has 4 different options. This is how you're going to do this part. David chooses 5 chocolates from 6 different dark chocolates. Okay, you've got dark chocolates, white chocolates and milk chocolates. From 6 different dark chocolates, 4 different white chocolates and 1 milk chocolate. He must choose at least one of each type. Find the number of different selections that he can make. Okay, he's supposed to choose at least one out of each type. And he's supposed to in all choose 5 chocolates. Okay, so let's write down the options: dark, white and milk. Okay, 1, 1 and 3 for this one. Okay, it can be 1, 3 and 1 for this one. It can be 3, 1 and 1 for this one. Okay, so these are the different options which I am listing, and then we're going to figure out the answer. Okay, it can be 2 of these, 2 of this and 1 of this. Okay, I have made a mistake here, and that is I should not take this into consideration. The reason being there's just 1 milk chocolate, so you cannot have 3 milk chocolates here. Okay, the rest of them are correct. The first one is 2 dark chocolates, 2 white chocolates and 1 milk chocolate. It can be, there's no other possibility apart from this. Okay, let's figure out the answer now. You want 1 dark chocolate out of the 6. I'm looking at this one. So 1 dark chocolate out of 6. So 6C1, 3 white chocolates out of 4 and 1 milk chocolate out of 1. This is the first one. Then you've got 3 dark chocolates out of 6, 1 white chocolate out of 4 and 1 milk chocolate. Lastly, 2 dark chocolates out of 6, 2 white chocolates out of 4 and 1 milk chocolate. Okay, then you're going to figure out the answer by multiplying and getting the answers in the bracket and then finally adding them up together. A password for Chelsea's computer consists of 4 characters in a particular order. The characters are chosen from the following: the 26 capital letters A to Z, the 9 digits 1 to 9 and the 5 symbols. There are 5 symbols given to us. The passwords must include at least 1 capital letter, at least 1 digit and at least 1 symbol. Okay, no character can be repeated. Find the number of different passwords that Chelsea can make. Okay, so you're supposed to choose 4 characters in all in a particular order. Okay, so it's capital letters, digits and symbols. Okay, so you're supposed to take at least 1 of each. So 1, 1 and it can be 2 symbols. It can be 2 of the digits and the rest of the 2 is 1, 1. And it can be 2 characters, 2 capital letters and 1 here, 1 here. There's no other option apart from these. Let's write down the answer. Capital letters were in all 26, so 26C1, 9 digits, so 9C1 into 5 symbols, so 5C2. I've worked out the first bracket firstly. Okay, then I'm going to put a plus sign. Plus sign actually indicates an OR thing. Okay, 26C1, 9C2 and 5C1. Lastly, 26C2, 9C1 and 5C1. You're going to solve this and you will get the final answer for this question. A library contains 4 identical copies of book A, 2 identical copies of book B and 5 identical copies of book C. A, B and C. You've got 4 identical copies of book A, 2 identical copies of book B and 5 identical copies of book C. These 11 books are arranged on a shelf in the library. Calculate the number of different arrangements if the end books are either book A or end books are either both book A or both book B. Okay, I'm going to arrange them. Overall, we've got 11 books here. Okay, so I'm going to write 11 dashes. Okay, so the end books are both book A. If they're both book A, so you've got this is also book A and this is also book A. So one option here, one option here. Okay, now you're left with 9 books in the center, out of which B is repeated twice and C is repeated 5 times. Okay, or once again 11 dashes. Okay, they are both book B, meaning if this is book B, you have to keep book B here. There's just one option here. 9 factorial in the center. Now you've got A and C in the center. A is repeated, there are 4 identical A's and C is 5 identical C's, so 5 factorial here. Finally, in order to get the final answer, you're simply supposed to solve this plus solve this and get the final answer. Calculate the number of different arrangements if all the books A are next to each other and none of the books B are next to each other. Once again, we're going to put 11 dashes. You want all the books A to be next to each other. If we notice, there are how many books? I'm just copying this here. Okay, we've got 4 books. You want all the books A's to be together. That means you're going to put 4 dashes. They have to be together, and none of the books B's to be together. I'm going to put the 2 B's to be. Okay, not in this case. Let's figure out the case where the book A's are together. So let's start counting. 1, 2, 3, 4, 5, 6, 7, 8 factorial. 8 factorial divided by 2 factorial because of the B being 2 book. There are 2 book B's and C is also 5 identical book C's. Okay, these are the total number of permutations when the book A's are together. From this case, if you subtract the case where A's are also together and B's are also together, then you will be left with all the cases where A's are together but B's are not together. Okay, let's find out the case where A's and B's both are together. So I'm going to put 11 dashes once again. Okay, I want book A's to be together and I want B's also to be together. There are 2 book B's. Let's start counting once again the dashes. You'll take this whole group as 1 unit. So 1, 2, 3, 4, 5, 6, 7 factorial divided by, since A and B are bounded together, so you won't divide it by them, but C has 5 books, so 5 factorial. Now from this answer, from the first answer, which was this, from this answer, if you subtract this answer, you will be left with all the cases where the book A's are together but book B's are not together. So 8 factorial upon 2 factorial into 5 factorial. From this you subtract 7 factorial upon 5 factorial and you will get the final answer for this. Find how many numbers between 3000 and 5000 can be made from the digits 1, 2, 3, 4 and 5 if digits are not repeated. You cannot repeat the digits. Obviously if it's a 4-digit number, so you have to put 4 dashes, and you want to make numbers between 3000 and 5000. That means the first digit can only hold 3 or 4. It cannot even hold 5 because you don't have zeros in this. So any number which will have 5 in the first digit will be greater than 5000 in that case. So that means you can only take 3 and 4 for the first place. That means 2 options for the first place. Okay, so once you put this number here, you will be left with 4 different numbers now, 4, 3 and 2. So your answer will be 2 into 4 into 3 into 2, and this will give you the answer. The second part, if digits can be repeated and the number formed is an odd number. Okay, if you notice, out of these 5 digits, the odd numbers are 1, 3 and 5. I'm going to separate the case where you have 1 as the last digit, or 3 as the last digit, or you have 5 as the last digit. If you have 1 as the last digit, there's just one option here. You have to make a number which is between 3000 and 5000. That means you have an option of having 3 here and 4 here. That means you've got 2 places here. Now apart from these, the digits, since they can be repeated, so you've got 5 digits in all, which is 1, 2, 3, 4 and 5. So you can have any of those 5 digits here, any of those 5 digits here. Okay, the second part where you are putting a 3 in the end, that means you have one place for this. There's just one option for the last place. Now here you can put a 3 and a 4. Okay, you can either put a 3 or a 4 here. That means you've got 2 places here, because digits can be repeated. So even if though you have put a 3 in the end, you can once again put a 3 here, because the digits can be repeated. Okay, you can put 5 digits here, any of those 5 digits here and any of those 5 digits here. Lastly, you've got one place for this. You can put a 3 here or a 4 here. That means you've got 2 places here, 5 and 5. So the answer will be 50 here, 50 here and 50 here. So the final answer will be 150. Okay, a box of 20 biscuits contain 4 different chocolate biscuits. Okay, let me write it down. 4 different chocolate biscuits, 2 different oatmeal biscuits and 14 different ginger biscuits. 6 biscuits are selected from the box at random. Find the number of different selections that can include the 2 oatmeal meat biscuits. You have to have these 2 oatmeal biscuits. That means now you're supposed to select out of 18 biscuits, which are 4 chocolate and 14 ginger biscuits. You're supposed to select now 4 biscuits, because 2 biscuits are already selected. Find the probability that fewer than 3 chocolate biscuits are selected. Fewer than 3 chocolate biscuits, meaning it can be 0 chocolate biscuit, or it can be 1 chocolate biscuit, or it can be 2 chocolate biscuits. Okay, if you take 0 chocolate biscuits, that means now you've got 16 biscuits. Have a look here. If you don't want to take any chocolate biscuit, that means you have 16 biscuits, out of which you're supposed to choose 6 biscuits. If you're taking 1 chocolate biscuit, that means now you are supposed 4C1, because if you read the question, it says a box of 20 biscuits contains 4 different chocolate biscuits. So all chocolate biscuits are also different. So out of those 4 chocolate biscuits, you have to take 1 chocolate biscuit, and out of the 16 rest of the biscuits, you are supposed to take 5. 2 chocolate biscuits, so 4C2 multiplied by, out of those rest of the 16 chocolate biscuits, you're supposed to take 4, because in all you want 6. You're going to calculate this and you will get the answer for this part. Thanks a lot for watching this video.